Good day everyone. So in our video today I'm going to explain how to solve problems related with polynomials that may include long division and also factorizing. Okay, so what is a polynomial? So a polynomial is an algebraic expression consisting of a number of terms in ascending powers of the same variable. For example, this is an example of a polynomial. So this is an example of a polynomial. So we're going to start with long division. Okay, so to explain better, I'm going to use an example. So let's say our f of x is equal to 2x to the power 4 plus 6x cubed plus 7x squared plus 15x plus 5. Okay, so there is our f of x. So we're going to divide our f of x, by x squared plus 3x plus 1. Okay, so we're going to use long division. So this is how we do it. Then we put our f of x here, which is 2x power 4 plus 6x cubed plus 7x squared plus 15x plus 5. Okay, that's our f of x, and then we're going to divide it by x squared plus 3x plus 1. Okay, so here's how we do it. First, we divide 2x to the power 4 by x squared. This should give us 2x squared. And then we multiply 2x squared by x squared. We get 2x to the power 4. Then we multiply 2x squared by 3x. We get a positive 6x cubed. Then 2x by 1, we get a positive 2x squared. Then we subtract. Okay, so this is going to give us 5x squared, and then we bring down the 15x, say plus 15x, and we bring down the positive 5 plus 5. And then again we divide 5x squared by x squared, so so x squared cancels out, going to be left with positive 5. Then we multiply 5 times x squared, we get a 5x squared. 5 times 3x squared, get a positive 15x. 5 by 1, get a positive 5. Then subtract. Okay, this one leaves no remainder. So if we divide our f of x by x squared plus 3x plus 1, our answer is 2x squared plus 5. Okay, alright, so let's do another example. This time we're going to divide, so let's say our f of x is x cubed plus 6x squared minus 3x plus 1. Okay, and we want to divide our f of x plus by x minus 2. So go back, use our long division, then put our f of x there, divided by x minus 2. Alright, so x into x cubed, we get x squared. X squared times x, get x cubed. X squared times negative 2, we get negative 2x squared. Then we subtract, we get 6x squared minus 2x squared, we get 8x squared. Then we bring down the 3, say minus 3x. Then we divide again, x into 8x cubed squared, we get a positive 8x. 8x times this, get 8x squared. Then 8x times negative 2, get negative 16x. If we subtract, we remain with 13x. Then we bring down the positive 1 plus 1. Then x into this, we get positive 13. And we multiply that, we get 13x and negative 26. Then subtract, we're going to have a remainder of 27. So this is the remainder. And this is our quotient. We say this is our quotient. So if we divide our f of x by x minus 2, we're going to have a remainder of 27, and our quotient is x squared plus 8x plus 13. Alright, so now if we say our x minus 2 is equal to 0, this means that our x is equal to 2. So this means that our f of 2 is equal to 2. So originally our f of x was x cubed plus 6x squared minus 3x plus 1. So now we're just replacing our x with 2. So we get 2 cubed plus 6 times 2 squared minus 3 times 2 plus 1. This gives us, so our f of 2 is equal to 27. So if f of x is divided by x minus a to get a remainder r, so if our f of a is equal to a remainder r, we call this a remainder theorem. But if f of x is divisible by x minus b and leaves no remainder, which means our f of b is equal to 0, we call this factor theorem. Factor theorem.